In this video, I'm going to start building a new compact CNC control box for the latest CNC machine that I am building. And in particular, the thoughts going into laying out components and powering for this 300mm wide, 400mm tall and 200mm deep ABS plastic electrical box. If you haven't seen the machine itself, I'll link to that video now in the information card and also in the video description. And for the rest of you who are remaining or have returned, I present to you my externalized internal monologue. I already positioned the power supply units in here, but I still need to mount these, and it does come with a galvanized steel backing plate, which means I can earth everything. It's also IP rated, I think IP 65 or 55. It's got this gasket here, but I have to admit it's pretty difficult to open and close these. My plan is to have the power coming in at the top, to have an NVR switch at the front, and then all the controllers and relays and stuff at the bottom, and to probably put the glands for the stepper motors and limit switches either at the bottom or one of the sides, probably the side away from the hinge of the door. Probably makes sense, so really this should go around that way. I've got my relay module there, and then right here I've got some of the barrier blocks. I think I'm going to have to put some standoffs on here and mount these kind of above in some way so the cables come round, and then everything just comes to this front here. Hopefully it's not too tight. Or I'll place the buttons here. I have bought some 24 volt momentary buttons with LED lights in them, so it should look pretty cool. Although that said, I could even put them on the top. I'm not sure how it would work out with the spacing just yet, because I don't have the NVR switch, and the one I was looking at looked quite big. 5 or 6 buttons here. Maybe keeping it all at the front is the way to go. Just crimped all these wires onto some small pink boot ferrules using this thing here. Really useful. I also have to think about what I want to do with the flood and mist controls. Where are they going to go, in fact? I really don't know. And whether I'm going to have another box like this with a variable frequency drive inside, and how that connects to these terminals here. Difference between this control board and the one that I was using on the original machine is that it has a 0 to 10 volt terminal and a PWM terminal, which is 0 to 5. So in theory I could have one going to the variable frequency drive and another which goes to a laser, and I think I probably will. I know the new or the latest version of the Phoenix controller is going to be different to what I've got, and I think it will have similar setup like this. But either way, the most important thing is the relay module board and interfacing between all the inputs and isolating the inputs, to be more specific with this. I've already planned the wiring before the enclosure arrives, so I'll be mainly following instructions I've drawn up for myself. Those will eventually be available on my Patreon page, but in the following video I'll take a little more time to talk about what I've done. This video will focus on my rambling thoughts while planning the layout. First I'll need to lay out the components, including the power supply unit, and mark and drill the mounting holes. The backing plate will later be earthed, which will provide safety in case of shorting, as well as help shield the components from electrical interference. Oh, landed that one pretty good. Making the enclosure small is going to be tricky, as it's hard to imagine how things will fit and the best process of assembling. I can imagine if I make a mistake, forgetting or needing to replace something, dismantling the machine will be like going backwards in time. It closes. That's the most important thing, I guess. I still don't know what I'm doing with the VFD. I probably should buy another one of these and place the VFD on that. In fact, I'm going to just double check that the VFD can fit in this. Oh, it looks tall. I don't think this is going to work. Yeah, that's not going to work. Maybe if I take the button off. This VFD is just too big, but I know you can get a miniature version from Banggood, so maybe I'll do that and have another enclosure with this to one side, so keep them separate. I'm going to draw on the enclosure where I think some of the components will go. The NVR switch will probably go up here, and the power in gland here. I want to have the buttons probably here, so this will be the hard stop for the Arduino. Then we'll have cycle, resume, feed, hold, and this will be the global soft stop. And this side here, probably going to put the limits somewhere. And I'll probably have the cable for the come out here, and at the top I'll have the, see this probe. Maybe I'll have the panel mount for the laser, and then another one that goes to the VFD. If I do have one going to another enclosure, that will send the signal out. On this side here, stepper motor cables. I'll probably have another button, which will be the Pi off button, which will connect to the terminals on the Raspberry Pi or Orange Pi. I might get an Orange Pi, and when it's pressed it will run a command that will shut that down. And then I'll probably need a couple of USBs for the mouse and keyboard, and then HDMI for a screen. It's a lot going on there. I'm still not sure about the onboard computer. I'd like to try and install and set one up, but it may be easier to connect the machine to an external laptop or PC. That stage of the build will be an entirely separate video. Anyway, to give me some versatility with this machine, and because I'm not a fan of water-cooled spindles, I'd like to wire a plug socket to a relay so I can control a hand router through G-code. This will also negate the need for an expensive CNC spindle and accompanying frequency drive. I'd also like to add a no voltage release switch to the enclosure, so if the power fails, the entire machine turns off and remains off if the power turns back on. I'm not sure whether I'm going to have enough space for this where I want to put it, in case there's not enough clearance for the power supply units. What I may end up doing is 3D printing a standoff for this so that it's a little bit raised. I also think I'm going to change it from the left side to the right side so that the wire doesn't stretch too far across. Because the NVR switch uses an electromagnet to keep the connection closed once pressed and the electricity flowing to the internal components, I'm going to also add an inline EMI filter between the switch and the power supply unit to prevent any unusual behavior from occurring. Okay, not much space, but God, that's a diabolical cutout, but no one's going to see it anyway. I don't really have the right size glands for the cable that I'd like to use for the power. Taking out the rubber in one, I could in theory fit this in there, but I think for now what I'll do is just drill a hole, wire it up, and add the gland later when one arrives in the post. I'll wire the incoming power and neutral cables to the NVR switch and then down to the EMI filter. I bought the NVR switch from Axminster Tools and the EMI filter secondhand from eBay. Luckily, seeing as I forgot to measure the EMI filter and that arrived after I assembled the power supply units, I had just enough space to bolt the filter to the backplate just above the power supply unit. In my previous controller I used a contactor unit as opposed to an NVR switch, which ran to individual on and off buttons. The method I'm using now is a little easier to do, but contactors have the advantage of being able to use lower voltages to start and stop higher ones. They also make better clunking sounds when starting and stopping. Now I should also mention you will need to use the right gauge wire for the power consumption, and that there is a direction with which to wire the filter and NVR switch, so make sure you read the instructions and follow any diagrams for those. Looks pretty neat. Okay, so I'm just going to demonstrate this working one more time. And you can see the lights on there. I'm just going to turn it off. And the filter's at the top there, so that should help reduce any EMI interference from this section working its way into that, although obviously this is quite close to the power supply units. Just feel like the off button's a little bit funny. I suspect this might be normal because of the mechanism of the switch, but if you happen to have the same one, I'd be curious to know if yours does the same thing. Anyway, that was the easier part of the build, and many of those illustrations on the outside of that ABS enclosure will undoubtedly change, so stay tuned for the following videos in this series.